Good morning, champs. Entropy is one of the most confusing ideas in thermodynamics. So instead of memorizing formulas, let's understand where they come from. First, the idea. Entropy describes how energy is distributed. If energy is concentrated, entropy is low. If energy is spread out, entropy is high. That is why heat naturally flows from hot to cold. Now, let's introduce the definition. The change in entropy is given by the formula ds equals delta Q reversible divided by temperature. This is very important. It only works with reversible heat. But even if a real process is irreversible, entropy is a state property. So we can always calculate entropy change using a reversible path. This is the most fundamental equation. Now, to make this usable, we connect entropy to measurable quantities. We use the relation T ds equals dH minus V dP. This equation shows something important. Entropy can change due to temperature changes and due to pressure changes. Now, let's apply this to an ideal gas. For an ideal gas, dH equals Cp times dt. And from the ideal gas law, we can express V in terms of temperature and pressure. If we substitute everything and simplify, we get a very useful expression. ds equals Cp times dt over T minus R times dP over P. Now, we integrate this expression. The result is the entropy formula you often see. Delta S equals Cp times the logarithm of T2 over T1 minus R times the logarithm of P2 over P1. This formula has two parts. The temperature term increases entropy when temperature increases. The pressure term decreases entropy when pressure increases. So heating spreads energy, while compression makes the system more ordered. Finally, there is one rule you should always remember. The entropy balance is written as delta S equals entropy transfer plus entropy production. And entropy production is always greater than or equal to 0. It can never be negative. If it is 0, the process is reversible. If it is greater than 0, the process is irreversible. So the key idea is simple. Entropy measures how energy spreads, and all the formulas we use come directly from that physical idea.